Your jobs are in danger. If you don't evolve, they are. You cannot be blinded by the output just because the numbers say so. Construction is actually brutal when it comes to keeping the records, maintaining the records, designing. Our design documents are huge documents, and we talk about, right? It's not easy to understand a drawing. You need skills to do that, and that's quite a manual and challenging process. And this is where AI fundamentally is reshaping how we are going to look at this, because this is human intervention is essential. Currently, most of the tasks are done by humans within the construction industry, and that's where the rapid needs are changing. So now the question is, of course, what will happen, how the construction industry, we contribute about 7 to 8% of GDP when it comes to construction sector. But if you see the number of construction workforce employed in some of these countries, highest you see is in the USA, about 10.2 million people. What is the number of construction workforce in India? Estimate says about 70 million, right? So when you see the percentage contribution to GDP versus the number of people that are employed by the industry, it tells you how productive our human beings really are when it comes to construction sector. But in general, construction sector around the world is known for very poor productivity. It's very manual dependent. A lot of people are needed to get the task done. But even in that, in Indian context, we tend to employ many more people for doing the same equal amount of production when it comes to construction. And that's actually one of the biggest drivers, which is going to be, for industry, this is a pain point. Because when you need so many people, the traditional model is that you hire people, you train them, you nurture them, and their skills develop. That's where they become more and more productive. But training is very hard. Retaining people is very hard. On an average, what is the time that a construction worker spends in a specific construction site? Any idea? Roughly 3 to 4 months. Within 3 to 4 months, people tend to change their jobs. How do you train people in such an environment? This is a messy problem for industry. And therefore, with the advent of AI, this is the key driver that is going to push the adoption really strongly, right? Does it mean your jobs are in danger? They are. In a conventional sense, they are. If you don't evolve, they are. The industry is going to evolve a lot, and you will be expected to evolve with it. But does it also create opportunities for new jobs? Yes. And I'll give you one simple example. I think recently there has been some innovations where you can actually predict, just based on the tender document released by a client, you can very easily identify what are the good risks in that, automatically analyze, and you can make a call very quickly. Do you want to bid for this particular project or not? Now, because of this, the bid submission capacity of the contractors have gone almost 10 times up. So on an average, if they were able to bid in 3 projects in a year, now they can actually bid on almost 30 projects in a year. So while the job in the traditional sense may cut down, in general, the volume of the work, the amount of work that people are going to do is also going to increase. So there are going to be jobs, but that's also in a transformed manner, right? But this is one of the key drivers. And this, we always tell that, yes, construction is one of the slowest sector to adopt new technology. But recently I was at IIT Delhi attending one of the, L&T is one of our sponsors, and there are a lot of students who are actually come from the same program. There was a conclave, and this was the first time the top senior leadership of the company was really visibly worried that the kind of change that has happened in the past 2 years is unprecedented. It has not happened ever so fast, and that is something that even now industry is noticing. And one of the primary drivers is the kind of skills that currently people have and the amount of work that we need to produce out of it, right? Our industry, this is again AI generated. Why should I not use AI? This is an AI generated representation of how construction is going to look like, right? We have the current opportunities. We still rely on a lot of manual work. Pushing off a lot of work, digitalization adoption. Our industry currently looks like this, where there's a lot of data that gets flowed through dashboards. People are able to visualize progress better, monitor better, and maybe drive the production faster. But we are actually not very far when it comes to looking at the landscape on the right-hand side that you see. where there's going to be a lot more robots, lot more drones automatically monitoring, live feedback from the site, and the role of the construction managers from the people is going to be very, very different. They have to monitor a lot more. They have to understand a lot more technology rather than just making sure that the concrete is getting poured on time and so on and so forth. Now with AI, the capability is that you can predict things much, much more faster or much, much more efficient. And the why things have become a little bit more what we call as a black box. In general, when you had a lot of data in the historical sense and you try to analyze them, you will actually understand more about the problem. Now your focus has shifted to get the best model out there and then start using it for some of the other things without having to worry too much about why the model is doing the way it is doing and so on and so forth. And I'm not going to go into the depth of what AI is, but I think that was a good definition. Try to mimic the human performance, but there are different these terms. AI, ML, deep learning, LLM is one of the perhaps tools or a part of it. This class is not about it, or this lecture is not about it. Just to gauge that my next set of slides would be understandable or not, how many of you know supervised machine learning and unsupervised machine learning? Okay, this is where I'm going to lose the audience, so let me not go to the technical details of it. Essentially, supervised is that you actually train the model, like I train you to do a certain task and the model is able to do that. Whereas the unsupervised is that I just give you the data, you figure it out and you give me the inference, right? So it could be like like the classic teachers, like we teach very simple examples in the board, in the classroom, and we tell you that this is how to solve the problem and you are able to solve the classroom problem very nicely. But then we give you a question in exam which was slightly different, and that's ideally if I would have given you such tough questions already as part of assignment, maybe you would be able to figure that out on your own, and that's like an example of an unsupervised learning, right? So let's not go into the technical details, but this becomes important for me to give us some reference later. In general, construction industry, AI needs data, right? AI requires a lot of information. Data could be of any form. In general, the information is of either text data, images, you have lots of videos coming up, audio, speech, sensor data, a lot of sensors getting done. They are giving a lot of information. Something new, which is called synthetic data. When you don't have data, you generate data because you want to make a model. And that's called synthetic data. So it's like AI does not even need data anymore. You can actually create your own data, make your model, be happy if you really want to be, if that's something that you want to do. But synthetic data has, of course, a lot of meaningful explanations and important applications. We'll see if the time permits, we'll be able to cover them or not. What do you think is the most amount or typical data composition? Construction sites, do they generate text more? Do they generate images more, videos more, sensor data more? What do you think is the highest amount of data coming from? Image is very recent because you have now access to cameras and a lot of people are putting. Conventionally, if you see, construction industry generates a lot of text data. People from the industry would relate to the DPR pain. Or if you have ever read a project report, any public project, any metro project, if you can just search online, there will be a detailed project report which can, I think last one that I read was of high-speed railway in Mumbai, Ahmedabad. That was 6 volumes, more than 1200 pages that I was supposed to read to figure out what this project is about, right? You also as a student generate a lot of text data to confuse us as a teachers that I will give you 35-page answer where all was needed was a 1 paragraph that I was looking as an answer. But this is, in general, humans tend to generate a lot of text data. And that's where I'll just cover a little bit of a text application that is possible out there, right? I personally work in the area of the construction safety, and that's my passion, and that's where we had some of the excess of, and again, this is not full picture out there. I just want to give you an overview of what's possible, right? So in construction site, in this particular case, what was happening is, every company wants to have a good safety culture, that people should not get hurt, and therefore they promote people to report. And these people are the workers at the site, right? They promote that these people should be able to report a problem if they see or safety issue that they see, and therefore company can be able, like they may able to take a corrective action and save the lives of the people, right? So this is the idea. And in general, when you go to construction site, I think majority of the time of people goes to reporting some or the other thing, either safety, quality, some sort of other issues, right? So we had access to such data, and we thought, okay, collection of data is one part, but the analysis of data becomes the tricky part. And suppose you as an individual enthusiast person, if you keep on reporting, but you don't hear back from your seniors about your reports, will you have motivation to report further? Right? So when somebody is reporting, you expect some actions to take in place, or you at least expect that there is some summary of it, something that happened that is shared back to you. So it's for companies also, it becomes very essential that not only you collect the data, but then you put analysis efforts also. So this is where we were motivated. Could we actually create a lot of issues, or could we actually analyze what is this data about? And if you can just see, I'm just giving a very brief example. Data, although there is a lot of text data, it's actually very bad quality text data. It's not very easy for us to understand, or maybe it's even more difficult for a computer to understand. I'll just give you some example. PTW, anyone knows who's not from the industry what does PTW mean? It's called permit to work. Becomes very, very, very important concept when you go on site. But can you expect a computer to know what is PTW? Very commonly reported. It makes sense for the people on the site, but it doesn't make sense for a computer to understand what does PTW mean. So this is the problem, that a lot of the data that will get generated will have a lot of information that only a civil engineer can understand. Maybe not somebody else could understand. So this is where you need to try to build a lot of domain knowledge, as we call it, where the civil engineering knowledge is necessary in order to analyze this data. It's not that a computer scientist will just come and run few programs and this automatically will start revealing interesting information, right? This is a very, very important aspect to remember. No amount of computer science advancements can handle such kind of an issue, which requires domain expertise. And this is where you need to strengthen yourself, okay? And of course, we were able to, it's a lot of challenging story. We were able to create some interesting application for, if we had access to such, let's say 12,000 reports in this case, we were able to create a very reasonable, good model. But the question that really was, once we started, I was very proud. This was my first machine learning model. And I was like, oh, I have done amazing work. It's giving me 85% accuracy. Very, very nice. Let me try to talk to some industry people. Would they find it interesting? And immediately they asked me, can I actually use it on my site? My site generates only 3,000 reports. We don't have 12,000 reports. Can I still use your model? We tested it and we find model doesn't work. The performance goes very, very poor when the data is less, right? So then becomes the challenge, okay, how can you actually make it learn for smaller companies? Because in India, there is large quantum of construction actually happens through smaller companies, which may not even have access to such data. And that's where we actually experimented a little bit more with the semi-supervised learning, where if in case you don't have large quantity of data to learn from, how do you actually develop models and how do you actually go about it? And this is, again, going about the research side of it, I'm just explaining, but I'll come back to my main point once more very, very quickly. Just to give you an idea that it's not just a click of button. Any machine learning model is just not a click of button. There goes a lot of processing in terms of making this data interpretable. And that is a domain knowledge expertise that is always will be required when it comes to even developing new interesting models. But the question is, I was very excited. My model is 85% good. At that time, there was nothing to compare against. So I thought 85% is amazing. Is this really, really good from the industry perspective? Or is it really okay to just focus on 85% accuracy as a number was the biggest learning? So when I took it to the industry, and the feedback made it very, very clear. My most optimal model, which is some 7.792, I'm not even going into those numbers, what is the interpretation of that, actually doesn't make sense when you actually look into the details of how the model is making the predictions. And that's where we realize that there could be models which are not optimal from a mathematics perspective, but they actually learn from how the humans also learn from, or their learning procedure is very similar to how humans learn. And this becomes very important. AI models could be fantastic, but if you want people to trust on them, the processing of the model should be mimicking somewhat what the understanding of the expert is. If you don't understand a technology, there is a very high chance that you will feel threatened by it. And when you feel threatened by it, you actually will take decisions to kill the technology and not readily adopt it. But once you try to understand, okay, this is why the technology is behaving this way, and this is why I also make decisions this way, and technology is also making decisions this way. Oh, there is some interesting thing that is happening, and that trust is something that drives the adoption. So this becomes one of the key learnings for me during this exploration, that just building random models is not good enough. You really need to talk about whether the model, how it is learning, is this matching with this expert in the domain? Would the people will trust the domain, could trust the model? How will my model work on one site compared to other site? If I train a model sitting in Chennai, will it actually work in the conditions in Jaipur, which is my hometown? Many such issues exist for machine learning models. And this is where the domain expertise is necessary to question the output of a machine learning model. You cannot be blinded by the output just because the numbers say so. You have to develop the ability to question the output or evaluate the output, whether or not it is making sense as per you. It becomes even more important to know your core domain when it comes to the AI technology, right? I'll give you more information. Now, of course, once you have basic information, in India, we don't even have an overall understanding of how many accidents are happening. So we are actually trying to analyze the newspaper data with the advent of large language models. Can we actually come up with a national level database of when the accidents are happening, where the accidents are happening? Because without this, we are right now trying to shoot really in the blind. Nobody even knows how big is the problem of construction safety in India, and therefore how do you even try to solve it? So we are trying to leverage the machine learning model, newspaper articles to create some sense of what's really happening. But the situation is not limited only to this. This is not my work, but actually once you have developed such kind of interesting machine learning models, you can actually predict the risks, safety related risks in the document as soon as the project starts. Maybe during the DPR stage itself, you'll try to come up with, okay, these are the kind of safety risks I'm going to have on my project because my method statement is like that, because your pre-trained machine learning models are able to inform you. So the idea is to use this knowledge that gets generated once to start using right from the beginning for the next set of project. That's where the key insights from the machine learning model starts emerging. At IIT Madras, one of my colleagues, Professor Murli, has been he's the, I think, only person I know apart from lawyers who love contracts. He is developing extensively tools on how to make interpretation of such complex documents, which are not only technically jargon of legal aspect, also construction aspect, also civil engineering, and a lot of interesting tools that he's generating. But text is just one type of data. We have numbers. We generate a lot of numbers. And this is where, again, we try to do an application of, could we actually use this machine learning approach to predict the properties of the concrete? I think it's a very common hackathon problem statement at this stage. It's not a solved problem. Our group has a lot of interesting perspectives on this, but based on the past data about what all was the properties of the input materials that have gone into making a concrete, there is an opportunity to try to predict the property of the concrete that is an output, right? And that is an interest. Now, there is a lot of success here, and if you get a good model, you can actually achieve, can you do the mixed design faster? Currently, mixed design requires a lot of efforts, it requires a lot of expertise. Can you actually do it faster? My answer is no, you should not do it faster, but question about from a machine learning perspective is, yes, can you actually advance the field in order to, can you reduce the number of experiments, can you reduce the number of cubes that to test it in order to gather an understanding better? Again, my answer is no, but this is where the research purpose actually drives this question, right? Because at site, it's really challenging to test so many cubes for assessing the quality of the concrete that is being placed. So it's a major bottleneck, major problem for the industry. And of course, it's very natural for them to have an interest in this also, right? I'll just quickly end with some of the application with the vision data, camera and the images that we generate. And this is actually quite challenging in terms of course, there's a lot of advancement, but I particularly work in the area of safety where we are trying to develop, okay, on the live, can you generate the risk profile? What is the kind of postures? Is the worker in some sort of a high ergonomic risk or not? A lot of work by my colleague where using the drone imagery, he's able to understand how much progress has happened in a particular construction site. This becomes $1 million question to solve because contractors and clients alike, they like how much construction has happened because then they can release the payment. So if you could do that automatically using camera images, using having access to BIM model, it becomes really, really interesting. More advancement, this is again not my work, my Professor Aritra Paul, my colleague's work. He's trying to make robotics application. Can you actually make a robot do tie of the human, this rebar cages, right? These are large quantity of rebars that you produce. Again, I think Shashwat is also contributing to this work. So a lot of interesting work around that. And finally, I will just lead with this. So virtual reality is another key technology that has emerged in the market. It has immense benefits in terms of design coordination, making sure that what you actually envision during the design stage actually gets constructed, detect a lot of problems early in the construction stage so that on site you minimize the rework. And also another set of properties another set of key applications is on training the people, because you can actually simulate scenarios that you don't want happen in the real world, but you can actually simulate those in the virtual world and train people for some of these scenarios that you don't want really to happen on the site, right? For example, you can simulate a plane crashing and how a pilot reacts to it in a virtual environment rather than the actual plane crashing, right? So we have the facility that we developed here and a lot of interesting work happening around that site as well. But really, I would recommend that you start thinking, what does it really mean to be a civil engineer anymore? Because these tools are going to be available very cheap, very accessible, very soon. But all these tools also have limitations in a way that they don't generalize well. If somebody has developed, you cannot directly use it. So your ability to question the output and maybe fine-tune the output is something that becomes much more valuable. So thank you so much. This is where we'll end.